So please stick it somewhere
I can
in the middle. Yeah, preferably in the middle.
Hold on a sec.
Try to say something.
Test.
Louder.
Test.
Yeah, should be fine.
Okay. All right.
Please stick it somewhere to your pocket.
Please,
You would like
presentation.
Yes.
now it's faster because if people will ask you questions after this section.
Sure. Right. Okay. Let me just rsync documents. Media. What was it? Oh yeah. What the hell is this? Yeah.
Do you need a presenter?
No, I'm fine. Yeah, it should be fine.
I have important information for you. After this talk, there will be some refreshment available in the lobby, so you can take some. And during taking the meal, it's a good opportunity to think if you want to give some lightning talk in the evening. And if you conclude that not, you can at least vote for some lightning talk. So think about it during your lunch. And our next speaker is Colin, so the floor is yours, Colin.
Okay, thank you. Can you guys hear me okay? Okay, great. So yeah, my name is Colin Walters. I work for Red Hat in the server experience group. I've worked on a lot of projects over the years. Worked on GNOME for a long time, but before that I was in Debian. I used to maintain Build Essential for a short amount of time. So I have had a variety of hats. Yeah, so let me just dive right in. Before I actually talk about what I'm doing, I like to start my talks by talking about why, because I think that really gives a lot of context and will help you just understand, because it's very important. So I care passionately about software freedom. It's just so critical to what we do, and it drives me. The second thing is I just find the whole process being fun, like seeing all you guys working with an international community. It's a lot of fun. But finally, of course, Red Hat Enterprise Linux pays the bills for me, and that also drives me. I want to ship software to our customers that, works well. Sometimes we're inconsistent. Let me just put it that way. So to start, Fedora, Debian, a lot of existing GNU and Linux distributions are structured in terms of packages. And there's a lot of good reasons for this, it turns out. One is that ultimately you need to have a source of software that's giving you security updates. And that the distribution model works well for that. But there are some downsides to this disassembly, is how I think of it. So, if you look at all of the infrastructure in the Fedora project, from Bugzilla to Bodhi to all this stuff, everything is package, right? Now, we do ship higher order delivery units sometimes, right? When you do an initial install, we give you a chunk in some form. Now, that could be the Anaconda net install ISO, which is actually a bunch of RPMs that are post-processed with LoRX. But the collection is assembled into a unit that does something, right? And of course, the GNOME Desktop Live CD, the KD Live CD, these are all higher order deliveries that are assembled. They perform a function. But the thing is, when you do an update, it's disassembled. It goes back into the parts, right? you end up managing packages. Literally, you are the package manager. And there's a lot of pluses to this. There's an incredible amount of flexibility to this, but there are some serious downsides to this as well. So a lot of the other, install images were just one higher order delivery, and there's comps too. And comps is kind of useful, but not really. I think it's, in young groups as objects starts to make it more interesting, because that starts to solve problems like, if we want to add a package to GNOME, then you get it, right? You are, a lot of people just don't want to know the implementation details, right? And comps, young groups as objects starts to move us into a little bit higher order model, but it's kind of a little bit late. I forget if it's the default still. I think it is in Fedora 20. Anyways, of course, there's the critical path, which I think that sort of went away, right? But a lot of this flexibility is good, right? You can find Fedora on ARM devices. You can find Fedora on your desktop, minimal cloud servers. And that's, of course, in contrast, like all the way at the other end of the spectrum, we have ChromeOS, right? It's like, here's this hardware. It's a netbook, basically. It runs a web browser. All the security updates are handled for you. There's a bunch of engineers who work on it. And the UI has some funny things, but broadly speaking, it works well for its intended purpose, right? You can't add or remove anything from it beyond web browser or beyond web pages. And they have extensions which start to break the model a little bit. But the point is that there's really two very different ends of a spectrum here, right? And so a good example of something that ChromeOS doesn't handle well is, what if you want to develop, well, it doesn't have a way to install software, but if you look at OS X, okay, here's a good example of OS X, right? Is that all the developer tools come with Xcode. Like, because all they really have is this base OS and app model, and so Xcode is like this enormous blob of stuff, and that model doesn't work well. What if you want to run an auto builder? Like, you have to run OS X plus Xcode on your build server. I mean, it's kind of wrong, right? So there's a lot of in-betweens. And of course, for Red Hat Enterprise Linux, we ship both server and client, right? We need to be able to walk and chew bubblegum at the same time. I strongly believe. We need to be able to do both of these things at once. And if you see my post on Fedora Devel List, a good example of a result of this sort of package mess where there's not a strong distinction between these two things is DHCP. A lot of our big customers do not want DHCP to occur by default, and we've kind of flipped the default over the years. It used to be Network Manager was just for clients, Network Service was for servers, but now with RHEL 7, Network Manager is on by default, and this becomes a bit more of a mess. So that's part of the problem, is that this sort of distinction is a little bit hard to draw with packages. Like, we really need a model where, at least by default, there is this higher order delivery, and you can track something that is targeted for a use case, I think. Right. And it's also very structurally bad, I think. I mean, some people say Fedora is for desktops, Red Hat Enterprise Linux is for servers. But this model really screws us in some ways, because it breaks Red Hat Enterprise Linux desktop if all of a sudden we later try and retrofit it for servers, and let's say we don't do DHCP by default. Right? Then all of a sudden, when you plug in an Ethernet cable in a Red Hat Enterprise Linux workstation, it doesn't work, right? So we can't do that sort of thing. We have to, how the separation between Fedora and Red Hat Enterprise Linux should work is, well, I have my own radical ideas, which I won't go into, but the point is that it needs to work the whole way down, because otherwise it just kind of breaks. Okay, so OSTree. Before I started doing anything in this field, I dove into all the stuff that's out there, like what OpenSUSE is doing with the Open Build Service, OpenQA. I researched a lot of niche GNU and Linux distributions like NixOS, which probably most of you haven't heard of, but they have some interesting ideas. I can tell you why it's impractical, but it's irrelevant. So I know about Open Embedded. I know about how we use JHBuild and GNOME. Like, I really dove into all the way we build and deliver software, and took a deep breath of what's out there. How Oracle Solaris does updates, their IPS, and how that interacts with ZFS. stuff like that. So OSTree was part of that research project, and I've been doing stuff in this field for years. And I've had a lot of failed attempts. But OSTree is the first thing where I hit on a kind of magic formula of stuff that worked. There's nothing revolutionary in it, really, like I'll show you. But again, it's a combination of things that do work. So OSTree is only part of the research project. OSTree is only about delivery, and you'll see that in a minute. I also researched the build side. So GNOME Continuous was a project where I basically have this toy OS, and I can just tinker with it and see how fast I can make it do continuous deployment. And that was a spectacular success. If you're using recent versions of GNOME, you're at least benefiting from that work. But I want to take a lot of this research and apply it to the Fedora and RPM world. Not everything that other people do we need to do, but some of the things we do are spectacularly bad. And the research project is about fixing those things. So OSTree is in many ways about accelerating what we already do. So it's not a new packaging format, really. So Docker and software collections are also about acceleration. Software collections is more in the package world in that everything does come as RPMs. Docker competes a little bit more with the package model. But OSTree is really about doing what we do with dpkg or RPM, like everything goes in /user, etc., just faster and more reliably. So this is probably one of the most important slides because, like a lot of you guys will think package, package, package. I think tree, tree, tree. And there's really, you can go from one to the other, right? When you install a set of packages, generates a file system tree, and that ends up on your disk. And a file system tree is composed of a set of packages. This is where the Docker model is kind of ugly because you can sort of make arbitrary changes. But with OSTree, I really want to restrict it to a tree is made from packages so that you can reproduce it and it has well-known content, etc. Now, an interesting way to look at this is OSTree requires naming these trees. Like up till now, you kind of run an anonymous set of packages in your /. A lot of people say, I run Fedora, or I run Red Hat Enterprise Linux, or Debian, or whatever. But really, you're running an anonymous subset of that. And in fact, one person could say, I upgraded Debian and it worked perfectly. The other could say, I upgraded Debian and it worked terribly. And they could both be right because they both have entirely different package sets, right? So OSTree is really about naming this state. And it's immutable. But you can upgrade it. So it's like a Git branch, right? Imagine we just took the RPMs and put them in Git. OSTree is like that, except it actually handles UID and GID and extended attributes and the stuff that you need to make an OS work. And it handles merging etc. I'll talk about this in a minute, but you can upgrade. So you can be running this. This is so this name, this Fed OSTree, you can see it's for Fedora 20, x86 64, and it contains the @standard comps group and Docker. And when you replicate this tree, you get exactly that. Exactly that. And yeah, like I said, the trees are versioned. And one of the things that I'm most proud of is that when you upgrade, it's fully atomic. So you can pull the power at any point, and you either have the old tree or the new tree reliably. So this is something that the ChromeOS update system has. OSTree is a lot more flexible than this, though. And this is why I think it's cooler. So you can not only install one tree and upgrade it, right? Like you could track the server Docker IO tree. You could track the GNOME desktop workstation tree. You can switch. So this is kind of, remember, the fundamental primitive here is going from one read-only file system tree to another read-only file system tree as an atomic swap. So when you run this command, OSTree admin switch to, what did I have here? Rawhide. So you can do an atomic swap from the Fedora 20 server Docker IO tree to the Rawhide version of that. You still have the old one installed. You can reboot into it. Or you could switch to something entirely different. You could install, the GNOME workstation. When you do this transition, remember, you don't have Docker anymore in the new tree. It's like you switch the result of yum install root between these two. But you do carry along all the changes to etc password. You carry along anything that's in var, like your DHCP leases. So it's not like installing a new operating system in that sense. It's kind of like I'm doing an atomic swap of the contents of /user, right? Because I'm just doing stuff like packages. Everything goes in user. It's not like Docker where it's totally freeform, right? So another really cool thing is you can go backwards. You can say, I want to deploy this exact SHA-256 hash, because these names are just like Git branches. They refer to a tree that changes over time. But you can pick any one. You can say, well, I'll talk about bisection later, which I think will really transform how people do local software delivery. But there's an important point here is that I have made a system that's less flexible than packages. And I think that's valid because it has a lot of other advantages. And so moving faster and being more reliably means, I think, that we need to shed a little bit of flexibility. Now, in my world, I'll talk about the proposal later, but we'll keep packages around. They'll just be a little bit more like raw material. One thing I hope that you guys take away from this talk is some upsides of OSTree, but also some downsides. Because if you can talk about positives and negatives, that means you really understand a system. Like if you talk to me about NixOS, I can tell you these are good things and these are bad things. So I hope you guys can take away some bad things. So I'll give you a couple negatives of OSTree, because I'm an engineer, and every system has positives and negatives, right? So every update in this model requires a reboot. That's just how it works. Now, I'll talk about live updates later, but that's a little bit of a research project. But yeah, this is an example of a downside. And also, of course, there's no model to take a tree and add or remove stuff from it. When you're replicating a tree, you're getting exactly that, and there's nothing that resolves dependencies necessarily. OK, so less flexibility than packages, but more flexible than the ChromeOS vision, right? So how this actually works is really simple. And this sort of thing came, a bunch of people have been doing this. NixOS does this. OLPC update does this. It's basically you boot into a chroot, right? So OSTree takes care of managing these chroots. It takes care of /boot. Because remember, a tree comes with a kernel. It's not like Docker containers, because, yeah, you are booting into it. It's fully capable of doing an atomic upgrade of /user and a kernel together. So there's, and the way it, yeah, so we have the chroots, and we just swap symbolic links in a couple places, and that gives us the atomic updates. Another really important aspect of this is it works on top of any Unix block storage and file system, which, because there are a lot of them, right? Samsung recently wrote F2FS. Red Enterprise Linux is still going to default to XFS on LVM. So I could talk about Btrfs. Btrfs allows some useful things, but I feel like a lot of people feel like Chris Mason's going to sort of descend from the sky, raise his magic wand, and all our problems are solved. Btrfs doesn't. Btrfs helps us with some things, but we need a lot more than that. Like you need handling of etc, for example. So OSTree is a model, works on top of any file system, and is very general purpose. So yeah, the implementation of upgrades, right? I've mentioned that we create a new chroot. So we basically check for the new version of the server Docker IO tree, get a new checksum. We download one HTTP request for each file we don't have. So this works quite well for small updates, right? An example I always use is, if GNOME Shell just changes one JavaScript file, you're talking about 6 HTTP requests. That's fine, right? If you're doing that swap from the server Docker IO tree to all the way to a workstation tree, it's over 60,000 or maybe more HTTP requests. It's kind of bad. So I actually just gave you another bad thing about OSTree. I hope you guys can think of more later. But we check out this root, and this is another thing that's different from OLPC update, is we actually do a 3-way merge of etc. So this is kind of what makes it more general purpose. If you look at other systems, you track changes over time, but the handling of etc is really tricky because you need to get new config files whenever you upgrade, right? So the way it works is pretty simple. we check out the new defaults, and then we apply your changes on top of them. And that's how you keep your etc password whenever you switch trees, is because your copy of etc password is just applied there. And to really make this etc merge work, I had to introduce /user/etc because we need the old defaults. One really cool thing that this allows, let me just run, since I've been talking a lot, let me just run a command here real quick. Config diff. Let me see. OSTree. So when I run this command, it's going to tell me what config files I changed. Right? And this is something I always wanted from Unix, right? Because you install a Unix system, you VI some files in etc or whatever, but then it's hard to reproduce that state later. Of course, there's stuff you can do. You can install etc keeper, but here that basic functionality is kind of built in. You just get it for free because I required it for upgrades. Okay, so also essential in this is I had to introduce user lib password. So this contains users like the LVM user, the dbus user, things that come from packages, right? So the idea is basically the OS, the RPMs, all that stuff goes in user, and you own etc and var. And you can blow them away at any time. I also have a model now where, var starts out empty. And the idea is at any point, you should be able to blow it away. And var starts out completely empty. You have a clean slate. So all your stuff like DHCP leases go away. And the way I implemented this is when I'm processing the RPMs, I look at what files they put in var, and I generate systemd temp file snippets. So the initial population happens on boot. Like var lib network manager happens when you boot, not when you install. So I've talked a lot about OSTree, which is a really generic file system replication tool that knows how to merge etc. And in fact, you can put dpkg packages in there, and people are doing that. So RPM OSTree is a project that I've had around for a while, and I really wish I'd pushed forward to production sooner because some people are excited about it. Is the project to do what I'm talking about and taking this RPM content and putting it in an OSTree repository. So there are a bunch of interesting things about this. One is that, for example, the SELinux labeling happens on the server side. We're not running through 5,000 regular expressions every time you upgrade. Let me show you the products.json file. So remember, OSTree is all about shipping multiple trees. So a couple interesting things here, right? So I'm building a tree for Fedora 20 and Rawhide. Remember earlier I gave that example of switching between the FedOSTree 20 x86-64 server Docker IO tree. You can also, this is the JSON file that's saying build all these trees, right? Right now I have the implementation of some stuff like user lib password. I haven't packaged it for Fedora because, I want to get buy-in before I try and push for all of this. So that's part of why I'm here. So anyways, this is an additional Copa repo. I'm really close to SELinux enforcing mode. Dan fixed one of the last bugs for this yesterday. I'm very excited about that. And this is kind of like what Anaconda is doing. We just need your base storage packages, right? Like XFS progs, all that stuff. By default, I'm removing the root password because we really need an initial setup process. If you actually use OSTree to replicate a tree, its etc password won't let you log in because it won't have any users. But anyways, so here's how I'm defining multiple trees, right? So you can see I've made one that has JBoss. I've made one that is a virtualization host. A good example of the potential shift in focus is the comps at virtualization group is really desktop virtualization. And this is where we can start to have well-defined, when you install this tree, you have a tree that's configured and ready to run Virt Manager, right? And that's, in fact, all it does. And going down a little bit, you can see these are all totally arbitrary. And we can make up whatever we want. But there's one that's GNOME, just the GNOME desktop. There's no apps in this. And then there's, in fact, remember, no way to install apps using it. You can use JHBuild, you can use other tools, but I don't provide you the tooling for that yet. I'll talk about that a little bit more later. You can, there's a KD one, and then you can see here I've made development and virtualization, right? So an example of where I want to go higher level with OSTree than just packages, right, is let's say you do a minimal install and you install glib2devel or glibcdevel. This is a completely worthless file system tree because you don't have make, you don't have GCC. It's total nonsense. I mean, Yum is happy to generate this tree for you, but we can go higher level than that. So most often, I think you just want all the headers at once. I mean, how we build stuff, the individual dependencies would still be there, but as far as delivery, right, we'll just give you all the headers at once. All the GNOME development headers, all the KD development headers, all the et cetera. So that's the products.json that RPM OSTree is using. Now, so here's the start of a proposal, right? All I want to do is I'd love to get the basic infrastructure for this into Fedora. So, we'll talk about stuff like the user lib password. I mean, maybe it should be a .d directory. Someone suggested that to me. Totally open to that. So that's going to be an ongoing conversation. But I want to get all the packages in Fedora, and I'd love to have this happening in Fedora infrastructure. So the idea is that this sort of fits with the Fedora.next focus. We can't test a combinatorial explosion of packages, but we can make well-defined subsets of those things that we do test. And once we do that well, we can move on. We can test more. So all it has to do is get push notification from Koji, and you have these pre-assembled trees in the repository. And what I'm going to talk about next is testing. Because really, any overgrown Perl script can turn source code into binaries, right? I think it's all about how quickly you go from source code to binaries to deployment to feedback, right? Get that feedback, go back to the source code. It turns, sometimes I've written code in GNOME that will only ship to customers 3 years later, right? And it's just dire because sometimes it just turns out it was completely wrong. So it's all about that whole feedback cycle. So testing happens really soon after building. But it's also important that you're able to replicate that tree. Because if a test fails, you need to be able to debug it locally. Like I said, I'll talk a bit more about testing next. So a possible next phase is that Bugzilla, you can actually file a bug against a tree, right? Now, if you really go down this path, there's a lot of implications from this, right? What if there's a maintainer for an entire group of stuff, right? I mean, it would make sense. A lot of people always file bugs against the GNOME desktop package, which is just an implementation detail of some stuff, right? Because very few people should have to care how it's implemented, right? And I mean, none of our users run packages. They run file system trees. A variety of them, right? And so all I'm doing is taking subsets of those and saying we ship this tree. So file a bug against a tree, right? That's something I'd love to see happen. And I'll talk a little bit more later about how we do layering beyond just these inflexible trees. So obviously, if we do this kind of thing, how it relates to Docker is an interesting question because Docker's got a lot of momentum. It seems likely that we want, you could obviously put OSTree inside a container, but I think it makes sense to have package systems inside there for now. But you can certainly take pre-generated trees and put them in Docker, and that's something we should probably support. Another thing that I will support, and the code is ready for this, right? If you understand, up till now, I've been talking about composing file system trees on a build server, and you just replicate it, right? You get exactly that. But there's no reason you can't do what we've all been doing up till now, which is dynamically assembling operating systems out of parts on your laptop. So, the tools will absolutely support downloading RPMs and committing them to the local OSTree repository and setting that up for the next boot. So you could be running one system and do an atomic swap from that to whatever else you want, whatever subset of packages. OSTree actually makes something like Gentoo a lot saner, I think. The crazy thing about Gentoo is like you're like compiling everything from source directly into your root file system without any testing. It's like, oh my God. But if it's set up as a separate root and you just reboot into it and see if it works, it makes it a lot saner, right? So allow people to experiment a lot more. And I think on the client side we should investigate separate application frameworks. Now, there's a lot of downsides to this, and it's a very complex topic. And I have not been working on it myself because frankly, we need a well-tested base before we even do that. And yeah, there's a lot of potential downsides. But having application mechanisms obviously makes OSTree a lot nicer because something like Docker for servers, it obviously just works well because you can have a base system and then you can install apps on top, like Chrome. This is the more complex side I was talking about. How much time do I have left, by the way? How much time?
10 minutes.
10 minutes, OK. All right, so I'll have to blow through this real quick. So yeah, actually, I'm just going to skip this one, but I have ideas for how you can add stuff on top of OSTree trees. A kind of package system based on it, but let's not talk about that for now. Obviously, live updates is something that I've thought about because rebooting for Firefox updates or Epiphany updates or whatever, it's kind of annoying. But on the other hand, OSTree has the positive that it doesn't break your running browser by removing all the files underneath it while it's running. So trade-offs. Yeah, I'd like to get to live updates. OK, so testing. I'm really passionate about testing because like I said, you can't just build stuff. It's all about how quickly you test it, how quickly